for me. One thing that I need you to remember before you factor, you need to make sure you have your polynomial in standard form. Biggest exponent first, work your way down, constants at the end. The other thing is never, ever factor when your leading coefficient is negative. All right. Beyond that, there's a series of 3 things to check for. What is the very first thing you're going to always look for when you factor? There you go on number 1. By golly, you're going to put GCF because that is the first thing you're going to look for. Now, I'm not going to fill in any of the rest of those boxes. If you look for a GCF, then we're going to figure out the rest of it. Look at that first one. Is there a GCF? 2x. Factor it out. What are you left with? What you're left with, x squared minus 16. Will that factor further? Because it's a what? Good. It's a difference of 2 squares. And how will the difference of 2 squares factor? Yes? Let's go down to the next row. Let's go right here. X cubed minus 27. Is there a GCF? No. How many terms you got? 2. So it's called a binomial. The only ways you know how to factor a binomial is if it's a difference of 2 squares or a sum or difference of 2 cubes. Is that a difference of 2 squares? No. Okay. Is it a sum or difference of 2 cubes? Which one? Sum or difference? Yeah, it's a difference. Okay, if it's 2 cubes, then that means each of those 2 terms have a nice cube root. What's the cube root of x cubed? X. What's the cube root of 27? Good. Do you remember the pattern for factoring a difference of 2 cubes? When you factor, rings a bell. Whenever you factor a sum or difference of 2 cubes, it's a binomial times a trinomial. What goes in your binomial is the cube roots of those terms, so the x and the 3. Don't worry about the signs yet. In your trinomial, the first term in the trinomial is the first term squared. The last term in your trinomial is the last term squared. Do you remember how to find the middle? It's this times this, x times 3. Now your signs. If you had me for Algebra 1, I did not teach you this because I'd never heard it at that time. I taught you just how to learn what the signs were. But since then, I have learned something called SOAP, which is an acronym for how to remember what the signs are in a sum or difference of 2 cubes. Same, opposite, always positive. Same. The first sign is the same as that one. Opposite. The first sign in your trinomial is the opposite of the first one. And the last term, the last sign is always positive. Same, opposite, always positive. Had any of you done that? You heard that before? Yeah, I never had either until very, very recently. I need you to understand, though, why that last term is always positive. Because to get that 9, we squared something. And when you square anything, what kind of sign are you going to get? Always positive. Yeah. Do we need to run another one with a cube? Let's do the second one. Is there a GCF? What is it? 2x. Factor out of 2x, what are you left with? That's a binomial. The only way you know how to factor a binomial is if it's a difference of 2 squares or a sum or difference of 2 cubes. Is that any of those? Good. It's a sum of 2 cubes. What's the cube root of x cubed? X, what's the cube root of 8? All right. 2x, what do I do with the 2x? You bring it down. He's a hobo. He's on the train and he ain't getting off, and you cannot make him get off. He's staying with you. Forget the signs. What are the terms that go in this binomial? X and 2. Now let's figure out what terms go in the trinomial. X squared, 2x, and 4. Signs. Same, opposite, always positive. Let's go down to trinomials. Does that first trinomial have a GCF? No. All right. People freak out because that's a degree 4. You know what that's called? You know, like degree 2 is quadratic, degree 3 is cubic, degree 4 is quartic. Right, it's quartic. You said that there was not a GCF. There is not. So I know that's going to factor, if it will, into 2 binomials. Now, people say, oh, what do I do with an x to the 4th? How am I going to factor an x to the 4th? So what's it going to be? Yeah, it's going to be x squared and x squared because your middle term, notice right there, is an x squared. So how do I factor 2x to the 4th? 2x squared and x squared. Now, here's the deal. I don't know how comfortable you are at factoring. I hope it's pretty good. I do factoring by guess and check. That's how all my calculus students do guess and check. Most pre-cal students do guess and check. Are you comfortable with guess and check, or do you have a method besides that that you prefer? You like box? Okay. Do you remember how to use box? Okay. Let me remind you how to use box. The first thing you got to remember is you got to have the GCF taken out. If you have a GCF in a box, it's totally messed up. Box goes something like this. I put this in this box. I put this in this box, right? And then I say, I need 2 numbers that multiply to give me, what's 20 times 2? 40, but add to give me 13. Negative 13. Can you come up with any? Yep. And I'm going to put those in those 2 boxes. Now, does it matter which? No, not a bit. And then all I look for is greatest common factors. Is there a greatest common factor in this row? Oh, wait, these are squareds. Sorry. You use whatever that x is right there. So x squared. Is there a GCF here in this row? 4. Is there a GCF in this column? Is there a GCF in this column? What signs do you use? You use the signs of whatever sits here and here. Minus, minus. So this is 2x squared minus 5 times x squared minus 4. And then you say, self, am I finished? Why? Yep, this is a difference of 2 squares. 2x squared minus 5 times x plus 2 times x minus 2. Is that, are bells going off in your head? You're saying, oh yeah, I remember. Oh yeah, I remember. Please, I hope that's the case. If you have trouble with factoring, come see me. We'll do some work. Next page. You remember how to factor when you got 4 terms? Grouping. Yep, grouping. I'm not going to worry about all these instructions over here. Let's see if we can factor this by grouping. You remember what the first step in grouping is? Pair them up. I'm going to pair these up. Please do not pair them up with parentheses. That'll screw you up. Don't do that. Is there a GCF in that first pair? X squared times what? Factor out an x squared out of that first pair. You're looking for a GCF in the second pair so that when you factor it out, what are you left with? 2x plus 3. Can you come up with something that you could factor out of negative 8x minus 12 to be left with 2x plus 3? Good, negative 4. Now the angels start singing right here because this and this are the same. Yeah. So what you're going to do is you're going to factor out that 2x plus 3 kind of as a GCF times whatever you're left with, x squared minus 4. And then you say, self, am I finished? And you say, no, because I got another difference of 2 squares. 2x plus 3 times x plus 2 times x minus 2. You doing okay? It's tough having a hard class or a core class at the end of the day. I know it is. I don't want to say it's a hard class, but some of you might. I hope not too much. Factor each of the following polynomials whose equations and graphs are provided. Okay. Look at that first one. How do we factor that? If we factor out a 3x, what are we left with? Yep. Self, am I finished? What will factor? That x squared plus 4x plus 4 will factor. How? I can rewrite it how? X plus 2, and we're going to call that quantity squared because you got a binomial that you're squaring. Yeah. Now let's look over at that dang graph. What's the y-intercept of the graph? It certainly appears to be the origin. What is the constant term in the equation? We're looking here at the equation right here. There is not a constant term, is there? So what is it? 0. Oh, wait a minute. The constant term is the y-intercept. Oh my gosh. You remember that? You did that back in Algebra 2. I promise you did. I know because we're doing it in Algebra 2. Let me just remind you of a couple things as we look through this. How many solutions is this function supposed to have? How do you know 3? The biggest degree is 3. If I set this equation equal to 0, what would my solutions be? 0 and if 3x equals 0, then x would equal 0. If x plus 2 equals 0, then x equals negative 2. And if x plus 2 equals 0, then x equals, wait a minute. I thought I'm supposed to have 3 answers, so I'm only getting 2. I got x equals 0 and I got x equal negative 2. Because, well, 2 of them aren't 0, 2 of them are negative 2. Yeah. I heard the word multiplicity. Have you heard that word before? If you haven't, don't worry about it. Multiplicity just means how many times is a number an answer. the total number of answers have to be that biggest degree. Let's move on. We ain't going to do that one. Let's do the last one there. Let's do the last one there. How would we factor that one? Grouping. All right, group. Clear them up. GCF? Times what? Keep going. The angels are singing because my 2x plus 5s are the same. So this is 2x plus 5 times x squared minus 1. Good. Difference of two squares. Now, if I set this equal to 0, what's 2x plus 5 equals 0? Means x equals, is negative 5 halves or negative 2 1/2 one of the zeros? Yep, right there. If x minus 1 equals 0, then x equals 1, right there, and right there. Yeah, 3 zeros, and we knew we were going to have 3. Now, what's the y-intercept of that? Let's look at the graph. What's the y-intercept of that graph? Negative 5. The y-intercept's negative 5. Isn't it right there? What's the constant in the function? The constant in the function is the y-intercept. Please write that right down here at the bottom. The constant is the y-intercept, and that's as far as we're going to go with that. We'll get deeper into that later. Are there any more notes to that one, or is that it? That's it. Okay. Solving polynomial equations and inequalities. Let me show you where the focus for us is going to be. It's going to be on that word inequalities, less thans and greater thans. The graph of the function x cubed plus x squared minus 6x is below. You see the graph. Factor f of x and use the factors to find the zeros. Factor that real quick. X squared plus x minus 6. Self, am I finished? Go. Good. So, if we set this thing equal to 0, what are our solutions? 0, 2, negative 3. Here they are. 0, 2, negative 3. Those are your zeros. Okay? Now, use the graph and identify the values of x for which each of the following equations or inequalities is true. Look at number 1. Where is f of x equal to 0? X-intercepts, which are where? So you're going to write x equals negative 3, 0, and 2. Now with your highlighter, where is that function greater than 0? What's it mean graphically for a function to be greater than 0? Above the x-axis. How come? How come? Because that's where the y values are positive. Good. So, how can you write? Oops, that's awful wide, but oh well. How can you write that section right there? Why parentheses? Because if we use the bracket, it'd be equal to, and equal to is not above the x-axis. It's on the x-axis. What else? And 2 to infinity. Good. Now, if you, see, most of you have similar colors to people around you. I was going to say swap with somebody who has a different color, but Where is this function less than 0? Below the x-axis. How come? How come? Because the y values are negative below the x-axis. Good. Where does that happen? Negative infinity to negative 3. And 0 to 2. Good. Look at the fourth one. Greater than or equal to. What do I do? Brackets around which one? The number 2 answer or the number 3 answer? The number 2 answer? Brackets everywhere? Not on infinity. Yeah. Now, why do we change to a bracket instead of parentheses? Because equal to. Good. Good. What about number 5? Same as 3. Parentheses still around the negative infinity. Could we have gotten those same answers without seeing the graph? You bet your boots. I'm going to show you a technique here. It's a very similar technique to the one where, remember when we had absolute values and we wanted to write it as piecewise? And so we had to use a number line? We're going to use a number line. This is a technique that you will carry with you into calculus, so I want you to really learn the technique, but it's easy. Let's pretend we don't see the graph. We're trying to solve this inequality, greater than or equal to 0. Highlight greater than or equal to, because if you don't, I'm afraid you will forget it. Now, completely factor. We already did that, didn't we, up at the top? Let's just write that down again then. What was it? X times x plus 3 times x minus 2? Greater than or equal to 0. Set each one of those factors equal to 0 to find the zeros of the function. We already did that. What were the zeros of the function? Those are the numbers we're going to put on our number line. So draw your number line. -3, 0, and 2. Now, what do you think we're going to do in each of those sections? Pick a number. Yeah. What we're going to do is we're going to pick a number that's less than -3, and we're going to see, does that number make this right here true or false? Okay? Come up with a number less than -3. -4, fine. Now here's how I'm going to write this. How many factors do we have in this yellow underlined stuff? How many things are we multiplying together? 3 things. So let's take -4. Does -4 make that plus or positive or negative? Negative. Times, does -4 make this positive or negative? Negative. And does -4 make this positive or negative? What's a negative times a negative times a negative? A negative. So are the numbers less than -3 numbers that will make the original inequality true or false? False, because they all make the thing negative. We need positive, right? We need greater than or equal to 0. So this section is false. This is a no. Pick a number between -3 and 0 and do the same thing. What'd you pick? -1? Fine. Does -1 make this first one positive or negative? Yeah, that's positive. What's a negative times a positive times a negative? That's a positive. So does that section make the inequality true or false? True. What number did you pick between 0 and 2? Somebody's going to pick a half or 2/3 or something. Okay, 1. Positive, positive, negative, positive, positive, negative. What do you get when you multiply that out? Yes or no? Do the numbers between 0 and 2 make my inequality true or false? False. We just got one more section. Pick a number. 3, fine. 3. Positive, positive, positive. True or false? True. So let's see where my answers are. My true sections were between -3 and 0, right? And where? 2 and infinity. Now what we got to do is decide what goes around those. I know parentheses around a infinity symbol. Keep in mind, what did you highlight right here? Or equal. I found the greater than parts. What about equal to? What? All of the, that's right. Don't all of these three numbers make that thing equal to 0? Yeah. So what? And that should be the same answer that you got right here. You don't have to have the graph. Are you doing okay? All right, this is a different one. Tell you what, here's what we're going to do. We're going to skip this table here, and we're going to go and we're actually going to do the work. So go to this piece of your, so what's it, about halfway down the page? All right, we're trying to solve that inequality, so what do I want you to highlight? The less than sign. Less than. Please, please make sure that that's what you pay attention to. So let's factor it. How many terms you got? How do we factor 4 terms? Grouping. What are you going to do there? Good. Let's factor out a -x squared times what? Good. What about here? Times remember, the angels are singing because those x plus 3's are the same. We're going to factor out those x plus 3's times what? Now I'm going to rewrite -x squared plus 2. I'm going to write it like this. But it's not in standard form. I know it's not in standard form. Now we're looking at number 2. Number 2 says set each factor equal to 0 to find the zeros of the function. If that first factor is equal to 0, then x would equal. What about the second one? Or what? If 2 minus x squared equals 0, then I'd get 2 equals x squared. How many answers does this little equation have? 2 plus or minus the square root of 2. Yeah, plus or minus the square root of 2. Now wait a minute. If we look back here on the graph, here's that -3. Could you have figured out that those two were plus and minus the square root of 2? There's no way. I couldn't have done it. You couldn't have done it. Nobody could have done it. This one has to be done analytically. It has to be done with algebra. All right. Next question. Are these 3 specific numbers going to be part of my answers? Look at what you highlighted. Why? Right. These numbers are going to be answers only if this is an or equal to. So what kinds of symbols are you going to have around your answers? Parentheses. Okay. Put these on a number line. Put these on a number line. What's the smallest of those numbers? It's all right. Can you ballpark square root of 2? Yeah, roughly 1.5. Yeah. All right. Pick some numbers. -4. What do you want to pick here? -2. What do you want to pick here? Yay! Thank you for picking 0. And what do you want to pick here? 2. Great. All right. How many factors do I have in this? Hello. How many factors do I have in this step right here? How many things are multiplied together? 2 things. So I've got to check x plus 3, and I've got to check 2 minus x squared. Let x equal -4. Positive or negative? Negative times, if x is -4, is that positive or negative? And a negative times a negative is a positive. Does that section of the number line make my answer true or false? Because I need to be greater than for those to be positive, okay? -2. Positive. Negative. Positive times negative. Are those, is that section of the graph going to answer my question true or false? True? True? I need to put a false in here. 0. Positive times positive is a positive. False, because those are bigger than 0. One more section. 2. Positive. Negative is a negative, which is true. How do I write my answer? True. -3 to -√2. And we already said we were going to have parentheses. And where? There you go. There you go. You doing okay here? How much more is there? So not much. Okay. All right. Look at this one. Completely factor. Let's factor it. It's already done. Woohoo! It's already done. What are our important numbers? Do I have to write the 2 down twice? No, sure don't. Now, what should you highlight? Less than or equal to. Does less than or equal to mean you're going to have parentheses or brackets? Brackets, because that's the equal to part. I'm not going to finish this one. You guys know what to do, right? I want to do that last one. This one. Oh, not that. What the crap is that? That ain't what I'm looking for. That one. That one. Consider this polynomial inequality. What do you notice about this one that's different from the previous ones? I don't know why that's white. Okay. I'm going to trust that you guys know how to graph on your graphing calculator. Okay. If we set that thing equal to 0, what's the equation going to be? X cubed minus 9x? Minus 3? Okay, let's just have a look-see at that. Okay. Can you see from there what the x-intercepts are? They're ugly, aren't they? They're not nice. So the question is, how do you find them if they're not nice? Do you know how to find x-intercepts on your calculator? Okay, let's just do a remember real quick. How do I find this one right here? Second calc. What am I looking for? Zeros. Now, yeah, left bound means I need to go to the left side of that thing. In this case, it means below. Hit enter. What's right bound mean? To the right of it, which in this case means above. Guess, I can just hit enter. Do you know what these two little arrows mean here at the top? That's right, your point is somewhere in between. Your calculator's not going to give you those two perpendicular, those two vertical lines, but I think it's pretty cool. If we just hit enter right there. Now, how do you write these? I want you, anytime you have to round, I want you to round to 3 decimal places. Okay? So what's that one going to be? Negative 2.817. We would go through this process. We would find the other 2 zeros using the same process. And then, let's see, well, snap, that's not what I wanted. How about a next page? There ain't a next page. Well, just a minute. If you look at the very, very last thing, let's see, what does ours look like? Let's make a little sketch of this on your graph there. So you've got a 0 where? Between negative 2 and negative 3. So put one on your picture. You got one between negative 2 and negative 3. This 0 right here is between what two integers? 0 and -1, so make a 0 between 0 and -1. And then where's this one? Between 3 and 4. So make those 3 zeros. And then make it go up, down, up. Don't worry about where your vertexes, your minimums and maximums are. Don't worry about that. Now, if you noticed, the problem said greater than or equal to. Is that what it said? So what parts of the graph would you be looking for? So graphically, what does that mean? On or above the x-axis. Good. So you would be looking for on or above the x-axis. Why don't you highlight that part with your highlighter? On or above the x-axis. Okay, we got it done. Now, I'm going to give you 2 days of homework, but listen to me. On the day 18, that's the factoring homework, very little of it is required.